Hello, good afternoon. This is a part of another part of the series where I'm constructing or I'm describing the process step by step for theoretical construction of uh, any structure like a building. Let's talk about a building on framework basis. So yesterday I was describing about excavation. So when a plot of land is selected to erect a building or to construct a building, we will make a marking layout. We will separate or individualize the boundary, the perimeter of the plot land, and we will make the marking and layout marking also for each underground element, and accordingly we will make excavation. And in excavation we said I talked about surface dressing, surface excavation, excavation over over area, and trench excavation. And actually these were the subdivision of the excavation. The major division of excavation comes to be shallow excavation and deep excavation. As I described yesterday, the shallow excavation is the excavation depth is limited to 1.5 meter, while any excavation is done below or exceeding 1.5 meter, we will categorize that type of excavation as a deep excavation. And deep excavation is usually done for pile foundation also, or for pile foundation. We usually do the deep excavation, and also for sometimes we go through a deep excavation to lay a raft foundation also. And another deep excavation, a trench excavation, also comes to be under a deep excavation. And trench excavation is a longitudinal excavation with depth either 1.5 meter or exceeding 1.5 meter. It sometimes goes to 3 meter, 4 meter, 5 meter also. And the trench excavation, major purpose of the trench excavation is to lay the, as I said yesterday also, to lay the to make for pipe laying or any circular structures laying. And while we do the excavation, or when we purpose the excavation to construct or to lay any, to construct any any structure, or to lay any prefabricated or already pre-made structure laying, we make a offset of up to a certain distance. Usually the offset distance usually 300 to up to 600 That is the offset area we excavate for to create the working space. Because in pipe laying also, persons are there to lay the pipes, to make the alignment, to lay the pipes, and to other necessary, to do other necessary. Similarly, in footing also, in raft foundation also, we make a offset distance to 300 minimum. That is the purpose of creating the working space where people come and go while performing their activity there. So after the excavation, the purpose now comes. After the excavation is finished, we will make compaction. We clean all the excavated area. We will make the final dressing also. The side walls also will be dressed, means to make aligned. Unevenness will be eliminated, and we do we do compaction of the excavated area. After the compaction is done, that area which now appear or which is formed, we call it the formation level. So that formation level is the soil, the excavated top level to receive the subsequent other structure. So first, the main problem for the structure is the attack by the dampness or water seepage or capillary action of underground water. So to resist or to block the water seepage or the capillary action of water, we make some what we call dampness to prevent the dampness or to mitigate the dampness of the excavated the formation level. We make some waterproofing seating like polyethylene sheet, 1000 gauge or 1200 gauge. We will spread there. Then the polythene sheet covered area now will be laid. Sometimes it is a necessity also, or sometimes it's not required. The stone shoaling also will be laid over the polythene sheet, or any other waterproofing bituminous based waterproofing membrane also sometimes is used. So over there we used stone shoaling. So stone shoaling is a granular material, a big significant granular material. It contains voids. So to avoid that or to clear away these air voids within the granular materials, we make a compaction through rammer or any vibrating compaction machine. After that area will be now ready for plain cement concrete laying, and usually that is the underground first layer of concrete element. So the plain cement concrete is specified somewhere the thickness to be 75 mm or 100 mm, and sometimes as per the soil condition, sometimes the designer specifies the thickness of the plain cement concrete to be 120 also. It depends on how, as per the design. When we check the drawing specifies in their section, the plain cement concrete section details. That details specify what is the thickness of the plain cement concrete. And another alternative name for plain cement concrete is also called blinding concrete. It is the thin layer of the concrete to align or to level the surface. Because now let's talk about footing. When we construct footing, we cannot put the footing, the concrete or the rebars directly in touch with the soil. So to prevent the direct touch of the reinforcement bar or the concrete to the soil, we given the protective layer in the form of plain cement concrete. So while we cast the plain cement concrete, we always make sure that there is a opposite distance from the footing area. Suppose if the footing area is 230 mm by 500 mm. So in all sides of the footing, we ensure always the provision of 300 mm, 300 mm or minimum 100 mm offset distance of the PCC. So why we put this offset 100 mm or let's say 75 mm? This is the purpose of allowing or the provision of this 100 mm offset distance is to facilitate the formwork, the shuttering, what we call shuttering for the footing construction. So here footing in when we are as per the drawing, because the designer designs, so as per the drawing design, the footing, there are various kinds of footings. Sometimes we call isolated footings, strap footings, another is the raft foundation, also, or bulk footing. Bulk footing is also called the raft foundation. It will the footing in bulk foundation or the raft foundation. This is the raft foundation is the combination of collective form of all the footings which we construct individually in another area. So so far as the footing is concerned, and after the let's connect back to the PCC. Let's consider PCC has been casted. This PCC sometimes casted on reinforced also, and sometimes reinforced also. But the reinforced, if it is a reinforced concrete, we will not use so much rebars. Only one layer or one layer reinforcement bar also is enough for the PCC. Usually it is unreinforced. So now the reinforced concrete or reinforced concrete structurally starts when we cure the PCC, because there is certain time allowance for certain time allowed for curing of the casted PCC, because the water is the main component, main agent for the concrete element to assisting to maintain the moisture content within the concrete. If we allow the evaporation of the self-contained moisture or the dampness or the water content of any concrete element dried away or evaporated at their initial setting time, the concrete element, which is designed to maintain a certain strength, will be lost. So that's why curing is required. So for PCC also, at least 7 days or minimum 3 to 4 days curing by water, or sometimes it is used chemical curing also. So chemical curing is if the construction is under emergency or fast track construction to be carried out at that time, chemical curing is an alternative form of water curing. But the best for the concrete element, best curing method for the concrete element is water curing. So when as we have studied, the first the day any concrete element or a concrete structure is casted, it gets an initial setting, or concrete starts hardening, or concrete start getting its strength or stiffness. The more it gets stiffened, the more strength it start experiencing, or more strength will start forming within the concrete element. So as the time passes, the strength of the concrete also increases. So in one day, usually 30% of strength, compressive, what we call compressive strength, 30% of compressive strength is obtained by the reinforced concrete casted in the first day, and after 3 days, after 7 days, after 14 days, after 21 days, and after 28 days, the concrete will get the design, concrete will get or will experience the design strength.